Here I want to show how DynLimits work. For that I will use inside the examples folder the restart server example. Restart server is just a dummy server that returns the number of requests per second on each path it's requested. For that I have a Docker Compose file here. I already started those two instances. That is the dummy server that serves as our backend server. The Redis instance that will be used for DynLimits. As you can see, those two are already running. So apart from that, what we need is here we have the catalog. Catalog is just a small script that we have here that runs a Python 3 server in this directory. So we have the indexed limits file here, that it's the catalog that defines the paths, endpoints, and API limits for each endpoint. And we will run this for our test of DynLimits. So we start it just here. It is starting to serve the file. So now we move into the dynamics limit test. Here we have our run script that just runs the server with dummy APK and the catalog server that it's running in Python. So the script that we use here is the load impact K6 tool, using this simple script that does one request per second to our DynLimits backend. So we just run this, and we can see it launches the test, and it keeps sending information about completion. Okay, it looks like it's working. If we edit the limits currently for the endpoint, we have 60 requests per minute. So this is the above script. It's not going to hit the limit. If I change to 10, just suddenly we should start seeing the rate limit the messages over here, because we were doing like 60 requests per minute. I can raise it again, just changing the file that it's served by the Python server. I put it to 100, and let's see, we are not rate limited anymore. I can change again, and now I just want 5 per minute. So the next time it's updated, it's rate limited again. So this is how the dynamic part works. Now I'm going to move to see how different instances of DynLimits can share the limits. For that, what we have here is a different definition. This time DynLimit is not going to be updating from the server. So this is the definition. It's a 6,000 requests per minute limit for this full endpoint. And what we are going to do is we have 3 different scripts. Each one will spawn a DynLimits instance, and will run I will run a script, a K6 script, that it's going to make request against this spawned DynLimits instance. Since it's 6, the rate limit is very high, but what we want to see is that it's shared across different instances. So what I'm going to, we can see the K6 file here. that it's just sending as many requests as it can. It's like, okay, it's 1000 requests per second. That means that it's like, it's going, I mean, a single instance should hit the rate limit, should be able to just hit the rate limit, but we are running 4 of them, so at some point every instance will get rate limited. Okay, so here I will run the script on instance 00, the 1, the 2. So we are going to do this and make those run in parallel, just to check after 1 minute how many OKs has been received from the server, because when we hit the rate limit we return a 429 status code. It's just waiting 30 seconds more. I can show you when in this screen I have the running servers. It's going okay, it looks okay, not high load, but here I have a base limit that we can see that with one single DynLimits instance we can hit up to, no, this is just without DynLimits in the middle. It's when we make requests against the Rexstat server, we can hit up to 40,000 requests per second, and this is something that we will use later to see how well it performs. So we finish it here. We can see in the top screen, in the top split, that we had like 15,000 or 15,000 OK responses and 70,000 that were rate limited. In the next we have again 15,000 that were correctly served, and the same. There are small differences because in the time that we run the first to the second, the window started sliding, so there are some requests at the beginning and the end that can be served not hitting the exactly 6,000 per minute limit, because we didn't start and stop exactly at the same moment. And next one is here is the screen that I was showing you. In this case we want to see what's the delay or the performance hit that we have when running DynLimits server. As I show you, this is the baseline that it's just hitting, just not throwing requests through the DynLimits server, Proxy server, but just directly to Rexstat server, and that's what's the fastest, the faster that can get, the fastest that can get. And now what we are going to do, we run the run baseline, and we are going to run the normal, this one. In this test we are going to create just a DynLimits server with a big catalog. That's something that must be taken into account, because it takes some time to load. Okay, takes some time to load all the data to Redis first, so we have sleep 60 seconds first here, and then we run the tests to see how well it performs. So let's run it. In this case it's creating the Docker file. As you can see below, DynLimits is just at 41% right now. This is and you can see also that the DynLimits Rexstat server Redis is the one that it's at 27% right now, because this is what it's doing is just iterating all the catalog that it's composed of 10,000 keys and 100 endpoints, and it's loading that into Redis. This is taking a lot of time, so probably the way to load the catalog into Redis can be certainly improved. But yeah, that's the reason why I've put the 60 seconds load time there. It's done, and now we are running the test. As you can see, the script below the create pasteur name is for the Docker container that runs the K6 script, and we can see that DynLimits is getting like a big spike of computation, 600%. It's not really good for the load that this is getting. So the test just runs for a minute, and we will see how the results are for that. How many requests did we serve? This looks like a weird error because we are getting a 502 error. Probably we have some issue in the code too. And yep, we can see we got up to 769 requests per second. That it's not great at all. We see that 432 requests per second were rate limited, and we have around 100 per second that it's another response. Probably there is some issue there that must be fixed. But this is just the proof of concept, so I hope you like it, and that's all. Next steps are to fix those other response and also try to improve the performance because 700 requests per second is not great at all. So thanks for watching.